Hello, and welcome to our monthly climate briefing today. Um, we are here at Climate Central. Climate Central is a nonprofit, non-advocacy organization of scientists, communicators dedicated to researching, reporting, and storytelling around the data and the science of our changing climate. At Climate Central, we develop and distribute broadcast-ready content for you to use in your communities and with your readers or your viewers. So today's webinar, we're going to focus on a lot. We're looking at February, we're looking at winter, we're looking at temperatures and rainfall. So there's a lot to cover here. So we're going to jump right in. I think Shell is giving you some guidance. If you have questions, please use the Q&A box. The chat box is closed, and I will field those at the end. So today we have Zach Labe again, and we also have a special guest, Teresa Crimmins, who will be talking to us from the National Phenology Network. So that's very exciting in our second part. So I'm going to start with introducing Zach to you all. Leading our discussion is Dr. Zach Labe. Zach's interests explore the intersection of climate impacts, future scenarios, extreme events, early warning predictions, and applying novel data science methods like machine learning. In addition to these research areas, he is very passionate about improving science communication and data-driven visualization. Zach was a scientist at NOAA's GFDL about this time last year before joining Climate Central. So, Zach, please get us started.
All right. Well, thanks for the introduction and thanks everyone for being here for another month. So we're excited to get started and talk about today a couple different areas. There's a lot going on in the climate system, but before we get started, just want to remind you all that in addition to these webinars, which are recorded and then available on YouTube after the webinar, we also have these report pages where you can go onto the website for each single month. You can see a recording of the webinar as well as download graphics, interactives, and content in blog style like information. So I recommend you check out the page after this webinar. And sort of to give you a roadmap, like where are we going and what are we going to talk about today? We're going to do a quick check on some of those sort of global climate indicators before diving really deep into what's going on in the West, because it's such a significant event both from this past winter and for the ongoing heat wave and snow drought in that region. And then we're excited for the special guest today to talk about early spring. So we'll transition to that. So let's dive right in and give an update on current greenhouse gases. So again, these are the drivers, of course, of human-caused climate change. And we're checking in this particular month because the latest data shows that we've actually just set another record for global methane concentration. So methane, in addition to carbon dioxide, actually also has a seasonal cycle. And this is the time of year it's around its maximum. So just want to give a highlight to that. We'll also be definitely checking in on carbon dioxide as we get towards May, which is also its seasonal maximum, and again, likely to set another record this year. So, okay, let's dive in and take a look first at last month around the world. So here's showing the global temperature anomalies from February 2026. Again, the word anomaly in climate science, what it really means is a departure from average. So those red shading colors were warmer than average in February. Blue shaded colors were colder than average. So we can see that there was actually quite a lot of large anomalies, particularly across the northern hemisphere. So it was very cold across parts of Alaska into northern Canada, and then a sharp contrast across much of the central and western US with really remarkable warmth. Temperatures more than 5 degrees Celsius above normal in those areas. Similar types of temperature contrast occurred across Asia, Europe, and Africa. And really, as a whole, the month was the fifth warmest on record. One particularly noteworthy statistic from February was actually the average global sea surface temperatures were upwards of the second warmest on record for February. And as we'll talk about El Nino at the very end, so we'll definitely be keeping an eye on those global ocean sea surface temperatures, especially later on this year. And so if we put that sort of in the long-term context, so I already said it was the fifth warmest on record. So here's showing the average global temperature for the month of February since 1900 on the left, all the way through this year on the right-hand side. So we can see there's that year-to-year variability, but the very clear long-term upward trend. And the warmest February on record was back in 2024. And so, what about if we zoom in on the United States for the month of February? So, here is showing sort of the conditions across the lower 48, where anywhere in that dark red shading you see on the map was actually a record warm month for the month of February for those locations. So, anywhere including states like Arizona, parts of New Mexico, and Western Texas, stretching up through Wyoming and even into Montana, all observed record warm February temperatures, continuing on how warm it has been this winter across the US. And we're going to talk a lot about that coming up in the talk. On average, it was the fourth warmest on record for the month of February across the lower 48. But particularly what was striking was the daytime maximum temperatures, which were actually the second warmest. So here's taking a look at those average maximum temperatures across the US on average from again 1900 on the left all the way through this year on the right hand side. So there's large year to year variability, but we can see there's that upward trend mostly due to human caused climate change. And we can put really this year in context. So even though we had some colder conditions, some headlines about snowfall across the east, that warmth signal, especially across the central and western US, really dominated the signal for the month of February and for the whole winter as a whole. So, in addition to those really warm temperatures across most of the US, it's also been really dry. So, what we're seeing here is the recent drought monitor. So, anywhere you see sort of the yellows, oranges, and red shadings, that's indicating that those areas are currently either abnormally dry or they're in actually drought conditions. So, really, much of the US for the last couple months has been persistently dry. And this is really directly related to what's going on in the West with the snow drought. So, about 91% of Western US stations have below average snow water equivalent, and we'll show lots of more statistics about that. So, it's been dry across the US, it's been warm, and there's really been a lack of snow. So, now let's reflect on the winters. So, December, January, and February conditions. And like I said, it's been dry. So, it was actually the fifth driest winter on record for the contiguous United States. So anywhere in those brown colors means it was drier than normal, and that darkest brown color was actually the driest winter on record. So anywhere parts of the Mississippi River Valley, thinking areas like southern Illinois, Missouri, Arkansas, had their driest winter on record, and much of that dry conditions extended across the southeast and the northeast, where it's been persistent drought-like conditions, especially in parts of the Gulf Coast, like in Florida. And so, what does that mean for snowfall? So, looking back at snowfall since October, really trying to capture that entire cold season because snow already starts falling across the West during that time of year. So, what this is really putting the snowfall amount from October through sort of where we are now in context. So, anywhere sort of in the red shading, especially that darkest red color, means that they had record low snowfall for this really winter season. So, many states across the West observed record low winter snowfall, and only a few areas across the East really had noteworthy above normal snowfall. You can see one area that really stands out is across sort of Western North Carolina and sort of South Carolina, where they had that strong winter storm with record snowfall in that region. So, really, that's an area, of course, that doesn't see much snowfall, per winter. So, that storm kind of dominated the signal there. So, again, overall, the story really is, from at least a climate perspective, an extreme event is what's going on in the West. And so let's take a look at now at some of the data from the West. So this graph is showing the total snow cover area, which as of early March was the lowest on record in this satellite observational product. So we are that little blue line that's really low, showing how little snow cover area there actually was. We weren't anywhere close to the average peak. That's that sort of gray shaded area. In fact, sort of the peak this winter was very much close to or at the lowest snow cover on record in terms of area. It was also sort of, if we put it in the measure of the duration of snow cover, some states like Colorado, Wyoming, Utah, and Idaho had actually 60 to 100 fewer snow-covered days than average this winter. And there's only a few more weeks and months really left in this season, so time is running out to build that really important snowpack in the higher elevations. And so what does that look like now? So this is showing the sort of a snow water equivalent compared to normal for watersheds across the Western US. The snow drought actually worsened since the last time we gave you our briefing update last month. And this was really, again, dominated by the record warmth. And I'm going to continue talking about that being one of the main drivers this winter for the record low snowpack. So anywhere in that red shading is saying that snow water equivalent in those crucial water basins is less than 50% of normal. And essentially every major river basin in the West experienced its first or second warmest on record. There were even striking observations that we have heard where snowmelt has actually been recorded well above 10,000 feet in the Colorado River Basin, just again, due to those really warm conditions where sort of the snow altitude was getting higher and higher due to those warmer conditions at lower elevations that just have not been able to build up the snowpack. And even when snow did fall in areas like around Denver, it really melted out quite quickly within just a day or two. And so Colorado has been one of the states that's really seen some of the worst conditions compared to normal in terms of their snowpack. So this is showing daily snow water equivalent for the state of Colorado. So we're that thin black line. So you can see we're sort of below that gray shading, which is sort of representing prior years. So anytime you're sort of below that gray shading, that spread indicates record low conditions. Typically, the average peak in the amount of snow water equivalent that's held up in the snowpack is around early April, but given current climate outlook and the weather conditions, there is not much promise for at least snow in the short term. So right now, again, record low snow water equivalent for those crucial basins across Colorado. And what does that mean? So that means for really important watershed basins, including the amount of water that goes in Lake Powell, current conditions show that the minimum power pool elevation projected being reached by December of the end of this year is 3,490 feet. So record low conditions, and there's very concerns for the important Glennon Canyon Dam that may no longer generate hydroelectricity if these current projections hold. So we'll be closely monitoring, especially in this early spring period, the amount of snow and water that may build up at the end of the freeze season to see if we can improve those conditions. But as we know, and we're going to talk about, there's those record warm temperatures happening this week across many of those same areas. And as a reminder, if you're not familiar with sort of the importance of snow out west, the West is really a unique climate across the US where they get a lot of their precipitation and in sort of their water refilling important reservoirs and the water table during the winter time. So it builds up snow in the higher elevations. And then during the drier summer months, essentially that snow pack begins to melt, refilling those reservoirs and lakes and all the water resources that rely on it. So if you don't build up that important snowpack across the West during the wintertime, you have less and less water resources for communities, recreation, for agriculture, for energy, and for ecology for the rest of the year. So that's why we really spend a lot of attention looking at snow water equivalent in the snowpack during the year. And I just want to highlight that we're having upcoming Climate Matters that will actually dive even more into the data, looking at sort of this water season as a whole coming out in early April. And so, like I said, the primary driver of this sort of lack of snowfall, this snow drought across the West, has been those record warm temperatures. So I want to dive in back to Colorado again, which, like I said earlier, has really been facing these severe impacts. And so on the left-hand side is showing temperature rankings for the winter season across just the state of Colorado. So anywhere in that dark red shading indicates that it was a record warm winter, or within those sort of the orange color within like the top 10th percentile. So most of the state was record warm. The graph on the right really shows how striking and how much of an outlier this winter has been in terms of the number of 60-degree days that were reached at the station in Fort Collins, which is located north of Denver along the Front Range. And so you can see that this winter had nearly double the number of 60-degree winter days compared to the prior records. So it's that red bar that's way above any other year, and records have been kept all the way since prior to 1900. So we can see that in addition to it's just been record warm, it's been such an outlier, particularly driven by those really warm daytime maximum temperatures. And this is a bit more technical of a visual, so I'll try to break it down, but I like it because it puts it in the climate context. So this is for the state of Colorado, and you have four quadrants here where sort of the it's showing on one axis, the x-axis, accumulated precipitation. On the y-axis in the vertical, it's showing average temperature. So if you're sort of in the upper right quadrant for that specific year, that means it was warm and wet. If you're sort of in the bottom quadrant, that means you're sort of much cooler temperatures, and then on the left, dry, on the right hand, wet. So what I want you to focus is actually on the upper left quadrant where the arrow is for the star for 2026. That's sort of all by itself. And what that quadrant, we're in this warm and dry quadrant, really highlighting how much warmer 2026 has been in Colorado and also pretty dry. So this year is really an outlier from the cluster of every single other year in the record. And if you're interested in this type of visualization, recommend checking out the Colorado Climate Center visuals that really put all of this in the climate perspective. So what about outside of just Colorado and across the rest of the West? So here's showing conditions from October to February for this year. On the left-hand side is showing average temperatures in the rankings. So anywhere in that deep orange color, that means it was a record warm sort of this water season since October. So you can see almost all states, at least somewhere, observed record warm temperatures, and it blankets most of the states, like in Utah, Colorado, New Mexico, Arizona, almost the entire state was record warm since October. And then on the right-hand side, I want you to compare sort of the left and right, because the right-hand side is taking a look at precipitation compared to normal. So what you might notice is that there's actually quite a bit of green on this map, meaning that many areas were actually at least slightly wetter than normal. And so this is what we mean by the driver of the snow drought this year has been those record warm temperatures. It's been somewhat wet in parts of the Southwest, even extending into Southern California. They've had a pretty good, rainy winter. However, it's just been so warm, even at those really high elevations of the mountains, that they just haven't been able to get that important snowpack built up. So this is really, I think, highlights the story of the snow drought and the sort of perspective we're in. And so let's zoom back out now and take a look at the rest of the lower 48. So you can see that anywhere here is showing the average temperature, the ranks for those states. So the dark red, that 131, what does that mean? That means it was the warmest winter on record out of 131 years of data. And so comparing, how many states observed record warm conditions to 0 states that observed record cold conditions. So, there's been tons of headlines, of course, about the cold conditions in like the Northeast in states like New York, Pennsylvania, up through New England. But when we really look at the long-term historical record, to be quite honest, this winter was unremarkable. So it was cold relative to recent winters, but that's just because our perspective has changed. That sort of long-term trend has been warming across the Northeast, so we're getting used to more and more of these warm winters. So when we occasionally do get a snowy and cold winter, it really stands out. To put this in another perspective, the state that had the most unusually cold temperatures, again across the lower 48, was actually Delaware, and it's still only ranked as the 28th coldest winter on record. So it doesn't even get, pair in comparison to the type of warmth and anomalous conditions we've had in the central and western US. Like I said earlier, it's been particularly driven by those maximum temperatures. So now this is one of those maps again, highlighting where that dark red color means it was record warm. This is for those daytime highs. So you can see again across almost the entire West, we had record warm daytime high temperatures. And a really striking statistic, at least to me, was that this winter had the second highest average daytime maximum temperatures across the whole US in that 131-year record. And the average high temperature this winter for the US exceeded 48 degrees Fahrenheit for the first time in our instrumental history. Again, so really highlighting, even though there were many of those stories about how cold it's been, the real big extreme event in climate story is the historic warmth across the West. And so we just recently here at Climate Central released a new report taking a look at how climate change influenced those temperatures across the West. So this is showing one of the new analysis and results from that report, looking at the whole winter as a whole, showing that many areas and states across the West had at least 30 to 40 days where we had the climate shift index being at least level 2. What does that mean? That means that climate change made those temperatures for at least a month or more twice as more likely due to climate change. So really showing how much that climate change is boosting that winter warmth across the West. And really one of the states that's an outlier here is across Arizona, where, many parts of the state had 40 to 60 plus days that were again boosted by climate change. And so, another striking statistic that I've been showing and talking about the winter the last 3 months, but actually, if you look a little further out, it's been really warm. So, the last 6 months combines were actually the warmest on record for the lower 48. And then, if you take a look at the last 12 months, they were the warmest 12-month period for that period on record. And if you look again at the last 18 months, they were the second warmest. What does that mean is that it has been really, really warm across the entire United States on average for, the last year and a half, 2 years. And with, again, those really record warm conditions all the way from the Gulf Coast up through the Pacific Northwest. But even when you take a look at this long-term period, like the last year, we can see practically everywhere has been above normal. And so, what does it look like going ahead? So, where are we right now? Well, the story this week is a major heat wave, and it's a heat wave that's out of season. So, Climate Central has recently released a couple reports talking about how spring is arriving earlier. We're going to hear more about that today. And we can really see again, today, this week is a classic example of one of those really early heat waves. And so, what this is showing, this is from our climate shift index for today. And anywhere in that dark red color means it's sort of maximizing out on our climate shift index, meaning that temperatures were made at least 5 times more likely due to climate change. And that's covering quite a large part of the country. In fact, this is one of the largest swaths of this climate shift index level 5 that I've seen in quite a while. In fact, we're already seeing tons of records being broken. In fact, preliminary data already suggests that potentially yesterday tied the national record for the highest March temperature at 108 degrees Fahrenheit. So we will definitely be paying attention to this for the upcoming week. Unfortunately, this includes the state of Colorado. So here's from the latest from the National Weather Service office in Boulder, Colorado, highlighting different cities along the Front Range and into the Rockies, taking a look what the forecast is for today through Saturday compared to the all-time March maximum temperatures. All of these locations are currently forecast to exceed their all-time March temperature record. It's essentially going to get upwards of 90 degrees or higher along the Front Range of Colorado. Again, it's mid-March. This is completely out of season. Even in locations like Estes Park, right at the entrance to Rocky Mountain National Park, is projected to exceed their all-time March maximum temperature by more than 5 degrees. It will be near 80 degrees right at the entrance of Rocky Mountain National Park. So certainly not helping their snow drought conditions for this current week with all of this record warmth in this huge heat dome across the western US. So if we look further out, what's the forecast? Unfortunately, it's more warmth. So if we look at the 6 to 10 day outlook, conditions are showing that the forecast signal is more likely for warmer than normal conditions across the West. If we look at the next month, this map looks really similar, highlighting again a forecast signal that it's more likely for warmer conditions across the West. If we look at precipitation, another similar story. It's dry. It's looking warm and dry, particularly across the West, and similar in the Northeast, slightly cooler than normal conditions are more likely than not. And so lastly, I know there's been a lot of discussion in the climate space about potential for El Nino coming up this year. So I just wanted to do a quick check-in. We want to highlight, and I'm going to keep saying multiple times in this last part, that there is significant uncertainty at this point in the year, but we wanted to do a check-in, and we'll come back to this in future webinars in more detail as we gain more and more confidence on the forecast. So here's taking a look at last month's average sea surface temperatures compared to normal. If you've been watching this map we've been showing for the last couple months, what we've been seeing is across that central Pacific where we look for conditions for whether it's being an El Nino or La Nina. We can see that sort of cool blue color starting to fade with La Nina. And what we're really starting to see is warmth starting to build up in the eastern Pacific right off the coast of South America. And recently, a NOAA Climate Prediction Center released an El Nino watch, and it's really related to this warmth that is starting to build both at the deeper ocean as well as in this region. So we can already see the tendency in ocean temperatures for La Nina to begin fading. And here's this chart showing what does it look like from our current seasonal forecast models. This is a technical plot, but basically what it's showing is a collection of these different forecast models that we use. That's all the thin little lines and colors. And so we can see here there's a growing potential across all of the forecast models for El Nino to be arriving this year. But as you can see, the lines, there's a big spread across the lines, meaning that the significance or the strength of El Nino remains very uncertain. Also, we're in the time of year, it's sometimes nicknamed the spring predictability barrier, where there's just more uncertainty in the forecast for El Nino towards the wintertime. So, what we can say now that there is an increasing and growing likelihood for El Nino conditions to start to begin to be more prevalent later this year, especially towards winter. But we cannot exactly give you, the strength of this current condition for El Nino until more certainty builds in the coming months. And so, what does this mean globally? So, of course, El Nino plays a significant role in impacting weather and climate around the world. Another thing in terms of climate it really affects is the global warmth. So there's a tendency during El Nino years that they're boosted a little bit in the global temperature. So what this graphic is showing is it's showing forecasts from, again, those seasonal forecast models for global temperatures. So on the right-hand side, that's your forecast starting and initiating in March through the end of the winter. So you can see that solid red line. That's the average of our forecast models. And what do we see? We see an increase in the projections for global temperature as we get later and later in the year. And so far, if the forecasts hold, I can say with a little bit more confidence that it's very likely particularly in 2027 that we may see a potential for a new global temperature record. So we'll come back to this in the next couple webinars in the upcoming months when we have more confidence on this forecast. So I will summarize conditions here again. And February continues to rank very warm, especially for global oceans across the US. That's been one of the big extremes. Actually, when you look at the whole globe, one of the big extremes has been in the West with those record warm conditions, the snow drought, which has big implications for water resources. Unfortunately, the forecast for this week remains bad with a record heat wave and heat dome across the West. And this is likely to continue, at least in terms of warmer than normal conditions, hopefully not as record warm through the end of the month. Our next webinar is coming up at the sort of the third week in April. We're really excited that Dr. Simon Lee will be joining us to talk about a topic we get a lot of questions about, and that's the changing drivers of U.S. cold outbreaks and extremes. So we're looking forward to him joining us then. So now I want to introduce our special topic and guest speaker for today, which is Dr. Teresa Crimmins, who is an associate professor in the School of Natural Resources and the Environment at the University of Arizona. She is also the director of the USA National Phenology Network, is really an expert in that area, and has been a long-time collaborator with Climate Central. And we're so excited and looking forward to hearing her talk today about changes in the timing of spring and where we are this year. So I will stop sharing my screen and turn it over to her.
Thanks very much, Zach. And thanks everyone for being here today. This is really exciting. And I'm happy to basically kind of follow along with a similar narrative to what Zach just laid out really clearly. The question that we face all season long when we get to this time of the year is it spring yet? And I can verify, I'm in southern Arizona. Down here, it has been very warm. It has definitely been very warm, and we have seen abundant signs of spring. We have had, because we've had really very warm temperatures all through the winter and the spring, and actually pretty decent rainfall down here, we're seeing a whole diversity of kinds of wildflowers that we don't see every year. So I've been getting out and enjoying it very much. But just like Zach said, it's not the same story everywhere across the country. And so one of the things that we do here at the USA National Phenology Network is produce this map every spring that's basically indicates locations that have reached conditions that are associated with biological activity, the beginning of springtime biological activity. And this map is an anomaly map. So what it's showing is whether those conditions are being reached earlier or later than average. And when we say average, we mean the climatological average period, so 1991 to 2020. And so locations that are shaded on the map that are red have reached the conditions associated with the start of biological activity in the spring earlier than average this year. And if it's blue, it's later than average. And this map matches a lot of what Zach just showed really pretty clearly. A lot of those locations in Colorado and in Nebraska, where wildfires are currently burning, have reached those conditions well over 30 days ahead of schedule this year. And again, that's notable. It's right in line with what Zach was showing, because if we're comparing this year to just the 1991 to 2020 period, that's recent past, and we're very much ahead of schedule compared to recent past in this year in those parts of the country. But again, we see kind of that later start to spring activity along the East Coast. Okay, so what's behind those maps? These maps that we refer to as the spring indices are effectively a thermal accumulation model, meaning what it is that largely drives plant and animal activity to begin happening in the spring is exposure to warmth. And that's especially true in temperate systems where there is a winter season where things largely go dormant. And so what we do is we basically keep track of how much warmth a location is being exposed to. And this is similar to growing degree day, to the concept of growing degree days, if you're familiar with that. But then the spring indices also take into consideration synoptic, what we call capstone events, which are basically multi-day warm periods, because those warm fronts that come through that result in sustained warm temperatures for a few days in a row seem to have a greater impact on prompting plants and animals to initiate their activity, more so than just straight up growing degree days. So we have 3 different models that we run right now, and we're producing 3 different distinct maps, and they're kind of misnomers. The first one is called the leaf index. The reason why it's referred to as that is that it was created using observations of when early season shrubs like lilacs and honeysuckles first put on their leaves. But really it's an index, meaning that it's a synthetic variable representing conditions that can be interpreted as effectively when is the very leading edge of spring happening. And so in this plot, this is basically what we're doing on a pixel by pixel basis on the map I just showed, where we're keeping track of over the course of time on the x-axis how much warmth has been accumulated. And then once you hit the basically the threshold, then you say we've reached that leaf index, or we've hit those conditions associated with the start of spring. Then we have a second map that we produce that usually is reached between 4 and 6 weeks after the leaf index. It's called the bloom index because it was created basically using observations of when those early season shrubs like lilacs and honeysuckles flower. But it actually is also a pretty good indicator of when overstory canopy trees are starting to leaf out. So we can see how things are happening with the bloom index. And then just this year, we now have a third index, which we're referring to as the late bloom index, which is effectively in capturing and representing kind of that tail end of the spring season. So we tend to think of spring as, when we think about spring from a biological perspective, a whole gradient of events. And really it's not just when those first very early season things start happening, like the crocuses and the tulips coming out of the snow, but it also encompasses when those lilacs start to leaf out, then when the lilacs flower, and then when your oaks start to put on their leaves, and then when the black cherries put on their leaves. And so the late bloom index is really indicative of the conditions associated with kind of the end of the starts, the end of things beginning in spring. And when we kind of really, from a biological perspective, summer is really, once you're done starting things, you're done leafing out and flowering, and you're now moving on to summertime activity like full canopy and full bloom, and then moving on to fruits. So when we run that thermal accumulation model, and this is what we basically generate. This is showing the day of year that leaf index, or that first index that's indicative of the very start of biological activity in the spring, is being reached. And that's kind of interesting, but it's not that easy to interpret, other than you can look at this and interpret it from a binary perspective, meaning which locations have basically seen the start of spring versus which have not. But what's more interesting, again, is when you get to that anomaly, you difference that day of year map for the current year to the long-term average, and then you can start to tell a story about, well, where is it happening very early and where is it maybe not as early? And then it does get more interesting when you pair this map that indicates the very start of spring with that second one, which is the bloom index, which is the model that is reached, the threshold that's reached usually several weeks later. And so you can kind of toggle between them and see that in some cases, locations that maybe didn't reach that leaf index very early are now reaching the bloom index early. And that's basically a function of a very rapid increase in thermal accumulation between the dates when those two events occurred. And so we like to look at these two maps together as spring is unfurling, to be able to kind of see how conditions are progressing, not just across space, but through time too. And really that's what prompted the creation of the late bloom index as well, because it allows us to show even further down as the season is unfolding what ended up happening. I don't have a map for that yet, because it's really just the Florida Keys that have reached that index so far this year. It requires quite a bit more warmth to be accumulated at a location for it to click over. So that's something you can keep track of as the season unfolds, and on our website, because these maps are updated daily. But one thing that's really cool, and what these maps in aggregate show, is just because the season starts early, it doesn't necessarily mean everything sustains early, or vice versa. You can have a really late start to spring and then have very warm conditions come on, and then things ramp up, and then you start rushing through all those onsets that constitute spring very rapidly. And those conditions and how they're playing out in sequence through the season have a lot of consequences for things like agriculture, like when we should plant or when we might expect to harvest. Definitely allergies. These locations that are seeing the start of spring earlier are also locations that are reporting really high pollen concentrations. The earlier start to spring prompts the plants that generate pollen that's allergenic to start flowering earlier, and oftentimes leads to a longer and a more intense pollen season. And then, as Zach was showing, oftentimes these very warm temperatures can be coupled with lower precipitation, or even if not, just the warmer temperatures lead to greater evapotranspiration. And then you have a situation where vegetation dries out, and it can be a greater wildfire risk. So these kinds of maps are helpful in all those kinds of applications. So if you're interested in learning more, we have a number of resources available on our website. The maps are updated nightly at that URL that's given there. And we make them available both as images and also a variety of raster layers, as well as KML and KMZ. So a lot of weather forecasters will pull those straight into their own broadcast systems and incorporate them into their broadcast. So if you're interested in doing that, you should be able to access it right there on the website, but if not, reach out. And we have an info sheet that's available on that URL as well that kind of goes into a bit more depth explaining exactly how the products are made. And as that kind of hinted at, Climate Central has done an amazing job of pulling the layers that reflect when those indices have been reached in the last 40 some years, and they've calculated some trends for us. And so we have layers for when both the leaf and the bloom indices were reached across the country in every year from 1981 to 2025. And what Climate Central has prepared is a product that shows the trend in when those indices were reached over that period. And so this is one of the maps that's just showing pretty clear patterns, as you would expect, that that very leading edge of spring is drifting earlier, and has drifted in some cases a whole lot earlier in just that last few decades. Okay, well, I can't dance around it anymore. The question that I always am prompted with when I'm introduced is, what is phenology? Phenology is what we just talked about. It refers to when seasonal events are occurring in plants and animals. So things like egg hatch or leaf out or flowering or fruit ripening. And the reason why we care to pay attention to this is that those biological events are so influenced, are so shaped by what those recent conditions have been, temperature and precipitation and day length too. And so as those conditions are changing, we're seeing a very clear response in changes in the timing of when these events are occurring. And what's complexifying the story is that a lot of events are being shifted earlier with the warmer temperatures, but to varying degrees. And not everybody is shifting, and not everybody's shifting in sync. And so things like biological interactions, like the butterfly on the flower there, is something that stands to be disrupted. And there's a whole raft of both ecological and economic consequences that stand to take place as in response to these kinds of changes. And so that was what prompted the establishment of the USA National Phenology Network, which is a program that's now based at the University of Arizona and funded through a variety of sources. We were established in 2007, mainly because scientists started to realize, when the Intergovernmental Panel on Climate Change research started to really come together around climate change research, scientists realized both phenology, or when stuff is happening in plants and animals, is one of the best and most visible indicators of how plants and animals are responding to these rapidly changing conditions. And most of the data that we have was coming from other continents. We really didn't have very good long-term consistent monitoring here in this country. And so the network was established primarily to collect and then store and then readily, freely share data and information about when stuff is happening in plants and animals across the country, so that we can understand how they're being impacted and what the impacts are going to be to humans and our livelihoods, all the species in the ecosystems too, and how we might be able to hopefully mitigate or adapt or contend with that. So one of the things, I'll just mention this because anybody can participate in this. One of the primary ways that we get those data that we use to better understand how things are changing is through a platform called Nature's Notebook, which is a data collection platform intended for folks of basically any age or education level or background. And it's based on standard observation protocols, where you're prompted to go out and make repeated observations on either the same individual plants at a location or animals at a site. And we have structured protocols that you follow that help you document what you're seeing in real time. So it's what we call status records. And so it's basically, do you see open flowers right now? Or do you see birds at the feeder right now? Those protocols are available for about 2,000 species at present. And there's a whole extensive training and support that is available to onboard folks either, and you can participate either as an individual or part of a group, which is a really rapidly growing popular approach for doing this. And I will mention too, we're so in the final painful stages of releasing a much improved, completely enhanced app that will enable a far more fun, engaging, sensical, far improved data collection and participation experience. That's coming online very soon. And I can't say a date because we don't have a date, but by the end of the month is really what we're aiming for. And so if you're interested in that, you can download the app now, and then you'll be prompted to download the new app once it's available, or you could just hang out and wait just a few more weeks. The cool thing is that we've got over 45 million records now that have been contributed through the platform that are readily available for download and use by anyone, both researchers, scientists, decision makers, educators, You can visualize the data using a tool right on our website, or you can pull those data. If you're fancy, we have an R package called RNPN, or we also have a query builder on our website where you can construct a query for exactly what you want and download it as a CSV. Those data are coming from over 33,000 participants across the country at over 20,000 sites. And since our launch, those data have been used in well over 200 publications, as well as theses and dissertations, and some national and global scale assessments too. So if you're interested in learning more about any of that, I encourage you to explore the resources on our website, usanpn.org, or sign up for our newsletters. There's a link at the very bottom if you scroll down at the bottom of the page. And that is where you can stay abreast of any studies that are being published using the data, the progress on the launch of the new app, the status of spring as it is unfolding, and a whole variety of opportunities that we have available for better understanding what's going on with spring this year and how that fits into the broader context of what's going on in the world. And then, excuse me, for further reading, this is a very long URL, so we can post it in the chat. But this is there's a couple of pieces that I worked on. I helped prepare with folks from climate.gov last spring, and I wanted to mention them this year just because they're so good in terms of explaining how can you interpret the leaf and bloom indices in tandem, and also why do we see sometimes the patterns that we see. So last year, the map on the right here was what the leaf index looked like for the country, and they recolored it, but you can basically imagine that the orange matches the red that we have on our map, and the purple matches the blue. So we had this funny kind of banding, or they called it a layer cake last year, where spring kind of went late, early, late, early, late, depending on where you were in the country. And that's always not always the most intuitive pattern for folks to understand. So we kind of walk you through it there and talk about how you could have years where you have an early start to the season and then it drifts late, or vice versa. Okay, I'll conclude there so that hopefully we have some time for questions, but here's all the different ways that you can connect with us. Thank you.